All right, what's up, mathletes? We're seeing 1.6 guided notes today about parent functions and transformations. Okay, so first thing we're going to go through and talk about all of our parent functions again here. So f of x is equal to x. That would be our linear. And our parent function of a linear goes right through the origin and through all of those diagonals, if I can make that draw correctly. Close. There we go. All right, the next one is going to be our quadratic. So that you can tell is a quadratic because it's x to the second power. And that's going to have a vertex down at 0, 0, and it's going to be this nice U shape. And as you can see, I'm a wonderful artist. All right, and x to the third is cubic. And that's going to look like this. So we got to make sure that we can identify these parent functions. And next is the square root function, or also known as radical. If you're in my class, we know it's a radical function. All right, and our next one is absolute value. Guys, I would definitely advise that you pause the video and fill these out on your own and see if you know these before watching me and just copying me do that. So go through and see if you can know what these are. This one you might not know, but you can definitely graph, right? You can graph all of these in your calculator. This is quartic because it's to the fourth power. And that actually has a little spot here at the origin that we hit, and there are two minimums that happen in a quartic function. Perfect. Something like that. All right, two minimums down there in quartic. And log of x is going to be our logarithmic. And we know that logarithmic approaches and then crosses here at 1. That approaches our y-axis, and 2 to the x is our exponential. We're going to see some approaching here as well. This is approaching the x-axis. And then we'll increase drastically. And sine of x. These are one of our trig functions. Okay, so this is specifically our sine function, but you might see a lot of these in trigonometry, but this one is specific to sine. All right, so remember if we know sine is always going to cross through our origin, and cosine starts, ooh, that was nice. And cosine will start at 1. And our last example here, 1 over x is our rational. So it's a fraction. We've got two parts of this graph, and they are both approaching the axes. So this is where you would use our union sign for our domain and range. Okay, so we're talking about transformations of a function. So a transformation is changing a function's graph through slides, flips, and rotations. Okay, so essentially it's taking these parent functions that we're talking about up here, and we're just moving them around. Okay, so we're going to start talking about this a little bit today, and I think a lot of us have seen this at least once. So when I talk about a slide, that is a translation, that talks about us moving up, down, left, and right. We're just taking that whole graph and shifting it. Nothing's changing to how it looks, it's just sliding. So I would take a vertex and just shift our whole graph with that vertex. So when we talk about another translation that's compression or stretch, when I compress, it flattens out or gets wider, so we might see our parent function of a quadratic do this. And if I compress it, it might look more like this. And that slope gets less steep. And when we talk about a stretch, we're talking about the opposite. So if I do my standard quadratic here, our parent function, it's going to get way more steep if we stretch it. Okay, it'll look more like this. That slope will get steeper as we stretch. And a reflection is just a general flip of the graph. And now we'll talk about a couple specific reflections. So over the x-axis, if I have a graph here, and let's say I have my quadratic up here, and I want to reflect it over the x-axis, I'm going to take this point and mirror image it over my x-axis, take this point, mirror image, this point, mirror image, and then we will have a reflected graph over the x-axis. Okay, and the same applies here when I'm going to flip over the y-axis. If I have the same graph, my same quadratic, and I want to reflect it over the y-axis, remember y's are this axis, so I'm going to take this point and reflect it over the y, this point reflected over the y, and this point reflected over the y. My reflection is also very good. There we go. You can see my art skills might need some work. But that's the idea, okay? So we're going to reflect it over those axes by just making sure that we have the same space on one side of the axis as we do on the other, and that'll flip it over. Okay, so let's check out a couple examples together. If I'm looking at this graph, and I'm starting with my solid line, and I want to look at what happens to my dotted line, I can see that I can take this vertex and I can follow it, all right? We're not seeing any kind of stretch or compress here, but I know that this vertex is going down 1, 2, and 3. So I can say that our quadratic has had a translation of down 3, okay? So we're going to translate down 3. And we'll look over here and we see our absolute value. And again, I'm seeing the same slope happening. Notice our linear lines, same slope, so we're not seeing a stretch or compress, but I can look at my vertex and see where it moved, and it just went to the right 1, 2, 3, 4 spaces. So again, that's another slide. So we're going to translate right 4. Okay, example 3, we're looking at a cubic. Remember, just look at that red line first. So I see a cubic, I see that I'm not moving left or right. So let's look at what happens here. If I take this point and it's about 1.5 away from the axis. Oh, look at that. It's about 1.5 away from the axis on the other side. So we can show that we're taking this graph and reflecting. So I can take these points and show that they're reflecting. So I can look at that as a reflection over the y-axis. But on this special graph, I can also look at this point and see that it could have been reflected this way as well. Okay, so on this special graph, we are just reflecting over an axis. And looking at example for our radical, or our square root, okay, we're looking at our transformation. It looks like it does more than just left or right, up and down. So I'm going to look, and I'm going to see 1, 2, 3 to the right, and 1, 2 up. So we had 2 different translations happening here. We can say we translated 3 right, and we translated up 2. Okay, flipping over to the next page for just a couple more problems on our notes before you get to your practice. This one is telling us how to translate it, and we need to draw a quick sketch of what that's going to look like. So I want to translate this 3 units up. So I'm going to take this vertex and go 1, 2, 3 units up and replace the vertex. And you'll see my slope here is up 1 over 1, so I can create a couple more points just to get a little more accurate of a movement. And so there would be our up 3, and the name of this is our quadratic. All right, I want to translate this function 2 units left. So again, I'm going to do the same thing. I'm going to take that vertex and go 1, 2 to the left, replace my vertex, and I see my very first slope point just to give me a head start. And I can draw that radical. On our next example, I want to reflect this over the x-axis specifically. Okay, so this is our cubic. We're going to reflect over the x-axis. That means we're flipping it over this line. So I can do that by taking a point and reflecting it across. Okay, I might take, so that's 1 unit away. I might take this point up at the top and go, that's 1, 2, 3, 4, 5, 6 units away. 6, and we're just a little inside. So we're just kind of trying to mirror image this graph. Same thing here. I'm going to flip that point to here, and then we'll have the same thing. We're going to go 6 up, and it's going to be a little bit inside that line. And then we can draw our reflected cubic. And our last example for today, we want to translate 1 unit down and 4 units right. So I'm going to take this vertex and go 1 down and 4 right. And I'm going to replace our vertex there. Okay, and then we can look here and see that our first slope is just up 1 over 1. And now we can draw that brand new absolute value graph. All right, guys, I hope that helped today. And if you have any questions, make sure you let us know.